problems, and they kind of just start kind of slow. This is a vector with x component negative 25, y component 40, right? So we are to the left and we are up. We're going to find the magnitude using the Pythagorean theorem, and we're going to find the angle using inverse tangent. Remind yourself that tangent is opposite over adjacent. So if the angle is with respect to the x-axis, then the opposite will always be the y component, and the x, of course, will be the adjacent. So if you just do inverse tangent of the y component over the x component, you will in fact get the angle relative to the x-axis. In this case, we're above the negative x-axis, which would really mean we're in the third quadrant. Same thing here. They give us an angle of 120 degrees from the positive x-axis, so we're flipping around there. We can use that angle. I typically do not. I typically just say negative 50 cosine of 60, comma 50 sine 60. I know I'm left and I know I'm up. Regardless, the result of that, meaning when you break that down, it has to be a negative x value and a positive y value. We're in the third quadrant. Again, this does work, but that's probably going to be one of the very, very few times you see me write it like that. I'm just reminding you that it does work, because cosine of 120 is going to be the opposite of cosine of 60. I'm almost always just going to use the reference angle, which would be 60 degrees in this case. This is the classic. You have a whole bunch of forces. In this case, there's two people pulling, and then the dog is pulling on this mule, it looks like. And we want to break these two down because we want to add them together. The way you have to add vectors together is to add their components. And so this is me breaking down F1. This is me breaking down F2. And then I'm going to add those pieces. So the 60 and the negative 20 is how much F1 is pulling to the right and how much F2 is pulling to the left, how much F1 is pulling up, how much F2 is pulling up. Add them together. And if I want the mule to balance those, well, then the mule has to be exactly opposite to balance. And so I want the mule to be a negative 39 and a negative 181. And if I want to actually find the magnitude and angle of the mule, then I'm just going to do Pythagorean theorem to find the actual magnitude. And then I'm going to do inverse tangent to find the angle. And again, I am below the negative x-axis because I am in the third quadrant. I am left and down. A plane, so I'm going to break the plane down. The plane goes from base camp to A, and then from there to B, and I want to know actually how far I am from here to here, right? Find the displacement. And so this is A. This is just 280 cosine 20, 280 sine 20, 190 cosine 30, 190 sine 30, and then I add those pieces. That's just how much to the right versus how much left. That's up, that's more up. Add them together. Pythagorean theorem to find the magnitude, inverse tangent to find the angle, and again, the angle is going to be north of east. That's the positive x-axis. If you are walking from B to base camp, well, then you just walk the absolute opposite direction, and you would go that same angle south of west. So down of left rather than up of right. Again, don't be too confused on what north of east and south of west are. We actually don't. That's not really an AP topic. That'd be more of just like in a book maybe. Okay, this is gonna be a three-dimensional thing. So we got a radar station, we got a ship, we got some stuff. So the ship is on the water, so it's got a height of 0, and then we're gonna break down that 17.3. And we can stay in kilometers. It's okay, everything's in kilometers, so just go ahead and stay in kilometers. So we're just going to do 17.3 cosine 46 to find this, 17.3 sine of 46 and put a negative because we're down. And then the plane, we do the same thing, 19.6 cosine 63 to find out how far right the plane is, 19.6 sine of 63 to find how down the plane is, and then of course the plane's height is 2.2. The difference between these, okay, this is down and this is down, so we're going to subtract 12 minus 8.9 is 3 point. This is also down, or excuse me, that was to the right and that was to the right, so that's how far right they are apart. And that's down, so if you subtract them, again, you get the difference, which is that 5.1. You're always subtracting. Sometimes you're just subtracting a positive and then a negative, so it looks like you're adding them, but it's always just the difference, right? You're looking at a delta. We know that this distance, Pythagorean theorem, is going to be the square root of delta x squared plus delta y squared plus delta h squared square rooted. Jet and wind, I'm going to break these down. The wind, the plane, or the jet is already just 300, 0 because you're going straight right. The wind, I'm going to break it down using sines and cosines. It looks like I didn't show that step, but this is for definitely right there. And that comes from doing 100 cosine 30. And then this, of course, is 100 sine 30. And then I'm going to add the jet and the wind components together. That's how we add vectors. And then I'm going to do the same thing we do almost every time at the end. I'm going to do Pythagorean theorem to find the magnitude, which is the speed. And then I'm going to do inverse tangent of the y value over the x value to find the angle. In this case, it's 7.4 degrees north of east, above right, which again is the correct angle. It is this reference angle in the first quadrant. Here I just have this crazy walk, like boom, 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 and I'm just adding up all these steps. So these vectors represent the 4 walks, and the total walk is the vector sum, which is just the adding up all the x's and adding up all the y's, and then doing the same thing we do at the end of everything is Pythagorean theorem and inverse tangent to find the actual angle, right? On average, what did I do? Well, I walked from here to here, 230, well, it looks like almost exactly 240 meters, and I walked below the x-axis, negative x-axis, about 57 degrees. Again, the displacement is the net. What did you actually do from start to finish? Well, it is just the addition of all those things. Air traffic control, same thing. So this is the same thing we did before. So this right here, 42, this radar station question, 3-dimensional Pythagorean theorem. Same thing here. I found out where this aircraft was located, left, down, at a height of 800 meters. So I put 0.8, these are all in kilometers. Left, down, 1.1 kilometers in the air. Delta is the difference. Again, subtract, subtract, subtract. And in this case, it's a minus, it's a negative minus a negative. So really, it's going to be a small thing because they're both way to the right. So they're only that off to the right. They're both way down, so you're not really off much down. And then they're both in the air, so you're only off 0.3 meters in the air. And then we know Pythagorean theorem is the square root of delta x squared plus delta y squared plus delta h, or delta z squared. And the last one, so this is just I, J, K stuff. Remember, I, J, K are the same directions as x, y, z. And so this vector, 3i plus 3j, is really just this vector. 3 to the right and 3 down. I minus 4j is really 1i minus 4j, which is really just this 1 comma negative 4. And then I want to do these combinations. I want to find out what d is. D is a plus c plus a plus b plus c. So I just add up their components and I get what d is. And I do the same thing for e. And if I actually want to find the magnitude and direction, then I'm doing the same thing. I'm finding the magnitude by taking the Pythagorean theorem, and then I'm taking, to find the angle, I'm doing inverse tangent. Okay, now I give you these bookwork questions, but again, most of the time the AP, nor will I use IJK. Lots of times we don't use north, south, east, and west, but you should be able to handle those, and clearly if they were on the AP test ever or in a college class, you should be familiar with that notation.